Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. We are continuing grade 7 chapter 2 Arithmetic Expressions. So in the previous videos we learned about the terms related to expressions and the brackets, the use of bracket, the importance of brackets in expressions, right? Now in this particular video we are going to learn about swapping and grouping. So how this swapping and grouping, does it make any change in the expression or the answers? So let us see, let us understand that. So here an example is taken, a simple example is taken. Like Madhu is flying a drone from a terrace. The drone goes 6 meters up and then 4 meters down. So write an expression to show how high the final position of the drone is from the terrace. So 6 minus 4 is equal to 2 meters above the terrace. So writing it as sum of terms, like it is up 6 floors up or 6 meters up means plus 6 and 4 meter down means minus 6. So 6 plus minus 4, because we are separating the terms here. Plus 6 is one term and minus 4 is the other term. And we get the answer 2. Now will the sum change if we swap the terms? So let us see. So what we have done, we have first written minus 4 and then we have written 6. In between there is a plus sign. So again the answer is 2. So it doesn't in this case, right? We already know that swapping the term does not change the sum when both the terms are positive numbers, right? This we saw earlier. Now here we understood that one is positive, one is negative, and if we are adding, still the sum remains the same even if we change the order or if we swap the numbers, right? Now the question is, will this also hold when there are terms having negative numbers as well? So take some more expressions and check. Here one was negative and one was positive, and we saw that the answer remains the same. So we will take now example of only negative numbers, and this we need to explain using the token model of integers we saw in class 6 textbook also. And those who have not learned class 6 textbook of mathematics, in the previous video I had shown you the token model. So let us take an example of all negative numbers and then let us see what is the change after swapping the numbers. So let us take two negative numbers, suppose minus 2 plus minus 3, right? So the answer will be, if both are negative, then we add, same sign means addition. So the answer is minus 5. Now let us change the order. First we take minus 3 plus minus 2. So again both are negative and we are adding. So 3 plus 2 is 5 and sign of greater. So answer is minus 5. Right? So if we take both numbers as negative, then also the answer remains the same, even if we change the order. Now let us see the same example using the token model. Now in token model, what we will do, 2 minus 2 means 2 negative numbers, and then 3 more negative numbers. So total how many negative numbers are there? 1, 2, 3, 4, 5 negative numbers. So answer is minus 5, right? So if you remember, like you may take the red chips, you can make red chips as negative and blue chips as positive, and use the token model to understand it better, right? So we have understood that if we take both the negative numbers and swap it or change the order, then also the answer remains the same. So we have understood that in an expression having two terms, swapping them does not change the value, whether one is positive, the other is negative, or both are positive or both are negative, right? So term 1 plus term 2 is equal to term 2 plus term 1. So now let us take an example with three terms, minus 7 plus 10 plus minus 11. So in the first case, if you see, we are adding the first two terms. Minus 7 plus 10 gives you plus 3. Both are different signs, so we subtract. 10 minus 7 is 3 and sign of greater, so plus 3. Then plus 3 and minus 11. So 3 minus 11 gives you minus 8, right? Now in the second one, what we do, we first add the last two terms. So 10 minus 11 gives you minus 1. Both have different sign. So we subtract and put the sign of greater. So minus 1. And here minus 7 is there. So minus 7 minus 1. Again, it gives you the answer in both the cases is same, that is equal to minus 8. Okay. Now what do you see? The sums are the same in both the cases, right? So again, while adding positive numbers, grouping them in any of the above two ways give the same sum. So now will this also hold when there are terms having negative numbers as well? So here they have taken two negative and one positive. And we have to explain this using the token model again. So I will take an example where all the three numbers are negative and let us see what is the difference. I am taking example of all three negative numbers. Right, so I'll take simple numbers because it is easy to understand. So minus 1, minus 2, plus minus 3. Now same sign means addition. So all three have same sign. So we add 1 plus 2 plus 3, which gives you 6. And it is negative. The greatest number is negative, sign of greater. So its answer will be minus 6. Okay. So here, like if I take this 2 first. So minus 1 minus 2 gives you minus 3. And again minus 3 is left. So minus 3 gives you minus 6. Now if I change the order of addition, let us see what is the difference. So first I choose to add the last two numbers, that is minus 2 and minus 3. So minus 1 remains as it is. And minus 2 minus 3 gives you minus 5. Right. So again minus 1 minus 5 is minus 6. So here also if we see that if we swap the number, if we change the order, then also if all of them are negative, we get the same answer. Now let us see the same example with the help of tokens. Okay. So now if we see the token number, the numbers, I'll write the question once again, minus 1 plus minus 2 plus minus 3. So minus 1, one token will take with a negative sign, minus 2 means 2 token will take, 2 negative tokens, then 3 more negative will take. So total how many negative tokens are there? 1, 2, 3, 4, 5, 6. And they are all negative, so the answer is minus 6. Right, so again with the token model also, we understood that if all the numbers are negative and we add them in any order, the answer remains the same. So we conclude that the grouping the terms of an expression in either of the following ways gives the same value. So first you add term 1 plus term 2, then you add term 3, or first you add term 2 plus term 3, then you add term 1, you get the same answer. As we saw in the question, minus 7 plus 10 plus minus 11, the answer was minus 8, right? So does adding the terms of an expression in any order give the same value? So yes, we saw that and we understood that. So, and we have explained it through token model example, and this is our conclusion, that addition of terms in any order gives the same value, right? So therefore, in an expression having only addition, it does not matter in what order the terms are added, they all give the same value. It also does not, the type of the number, whether all are positive, all are negative, or some positive, some negative, doesn't affect the answer the answer remains the same. Now let us consider the expression having multiplication and division also, without the order of operation specified by the brackets. The values of such expressions are found by first evaluating the terms. Once all the terms are evaluated, they are added. Now, this is the question. 30 plus 5 into 4. So we have learned how to identify the terms. So terms are, I'll just remind you that terms are separated by positive sign, plus sign. So this is one term, 30 is one term. Similarly, 5 into 4 is one term. So you should remember that the terms are first solved. So we solve this first. 5 4s are 20, 30 remains as it is. So 30 plus 20 is 50. The expression 5 into 3 plus 2 plus 78 plus 3 is evaluated as follows. Let us see. So 5 is 5 into 3 plus 2. This together is one term. Why? Because the plus sign is here, not the sign which is inside the bracket. And second term is here. Actually, there is a mistake in the textbook. There should be a multiplication sign. So 7 into 8 is another term, and this 3 is the third term. Right? Now, when 3 plus 2 is added, it is first evaluated. So you get 5. So 5 5s are, and it is multiplied by 5. So you get 25. Then this another term is evaluated. So 7 8s are 56. Right. So now what you get, this gives you 25. 7 into 8 gives you 56. And then you add 3. So then it is simple. 25 plus 56 plus 3 gives you 84. So what is most important here is you need to identify the terms. Right. Now here there is a question. Manasa is adding a long list of numbers. It took her 5 minutes to add them all. And she got the answer as 11749. Now then she realized that she had forgotten to include the fourth number, that is 9055. So does she have to start all over again? That's the question to us. So now we just saw that adding the numbers in any order doesn't make any change. So we can simply add these numbers, whatever answer she got, 11749 plus 9054, right? So that's enough. So we can just write here, she does not need to add all over again, right? So we will write here, no. Okay, so in mathematics, we use the phrase commutative property of addition instead of saying swapping the terms. Okay, does not change the sum. So swapping the terms, we use the word commutative property. Similarly, grouping does not change the sum. That is known as associative property of addition. So you have to remember the two properties. One is commutative property of addition, which is swapping the terms, and associative property of addition, that is grouping the terms. So two properties you need to remember. Now let us see the swapping the order of things in everyday life. We'll take some example. So here Manasa is going outside to play. Her mother says that wear your hat and shoes. Which one should she wear first? She can wear hat first and then shoes. Okay, that doesn't make any difference. Or she can wear her shoes first and then the hat. So Manasa will look exactly the same in both the cases. Fine. Now let us see a different situation. Now mother says wear your socks and shoes. Now the order matters. You cannot wear shoes first. Right? First you need to wear socks and then shoes. Right? If she changes the order here, she will be uncomfortable and look different. Right? So this is the example, real life example of the properties which we learned just now. Okay. So we will continue with the chapter, explanation of the chapter in the next video. Thank you.